Hi, welcome back to the breadboard. Let's talk about power supplies. Every time you build a project, you need to power it somehow. That may be 5 volts, it may be 9 volts, it may be 12 volts, depending on what you're doing. And if you're getting into more home automation, office automation, or industrial kind of control applications, then you'll find yourself tending more towards 24 volts supplies or even 48 volts if you're making, say, a home-built CNC and you want to optimize your torque on your stepper motors and things like that. The higher voltages typically are used for also things like LED lighting, etc., etc. Now, where do you get your power supplies from? I think a lot of you might just say, well, I go on eBay and find one that's the right voltage and current, and then I just order the cheapest one I can find. And that's maybe all well and good for many of the projects that you do, but it isn't necessarily the best choice depending on factors like reliability, time to get a replacement, features that are built into the power supply. You know, what does it do when it gets overloaded? Is it going to shut down if you overload it too much? Is it going to protect you with short circuits or over current protection or over voltage, under voltage? If your mains goes off or is noisy, what is that going to do with your power supply, etc.? There's a lot of factors that will go into or should go into your selection of a power supply. And what I want to show you here is a few power supplies I've got. I've got some cheap ones from eBay. I have some medium range power supplies, and I have specifically here one high-end power supply, which I'm going to jump right into another video once I've done this one to have a closer look at. Now, the real question I think when you're buying or building a power supply is, what is your time worth, and also what is it worth to you if it fails and you're either damaging something or you have time down for a piece of equipment, maybe a CNC. You built yourself a home CNC, you've got a little home business going, and all of a sudden your 48 volt or your 24 volt power supply that's driving it blows up because it wasn't very well built or it just wasn't high reliability. Now you've got to go get another one. If you've got to go get one sent from China, it could take you a month, 2 months to get there. You know, certainly where I live in Canada, most everything from eBay that comes from China takes at least 30 days to get here. It's very rare, unless I pay the extra shipping cost, to get it here quicker. So you want to be sure that your power supply is going to be suitable for the purpose, so fit for purpose. The second thing is, do you want to be able to monitor your power supply? Yes, you could put an external power meter on it and things like that to monitor it, but you want to be able to have something that maybe is built in. So your higher end power supplies may have extra features that tell you that the supply voltage is at the correct level. You may be able to adjust it. It may have indicators that allow you to control how it will shut down if you go into an overcurrent mode, and maybe even be able to provide power level out as a signal that you could pick up with some kind of microcontroller or PLC. So anyway, I've got a few on the bench here. I'm just going to go through them. As over the coming months, we're going to have a close look at different types of power supplies, and I'm going to be continuing the build of my bench power supply, because I still feel that even though, you know, if I was doing this for a project, I would probably just buy one off the shelf from a reputable source. It's always good to know how a power supply works, both linear and switching ones. So the best way to do that would be to build your own. Anyway, let's go have a closer look at the ones I've got on the bench here, and we'll talk about each one and what its features are and things like that. Now, obviously, the most common kind of power supply that most of us use are simply batteries. Most of our small projects and things like that, you can run them off of a 9 volt battery like these. I've just got these for some remote controls and things like that usually change the battery once every year or something. They're great for that kind of thing. But if you've got a higher powered project, these are not going to last very long at all. And they're not cheap either. So, you know, several dollars per battery, it's not necessarily a good option. But for very low power kind of systems, or ones that you use very intermittently, very convenient, very easy to use. So that's batteries. And of course, you've got the AA's, the AAA's, which are usually 1.5 volt. You've got lithium ion, nickel metal hydride, etc., etc. Different voltages, all low voltage. You can obviously stack them up in series or parallel to increase capacity or increase the voltage for them, but you've got to recharge them, which means you still need a separate power to charge them and things like that at some point. And if you've got the alkaline kinds like this, then once they're done, they're pretty much dead, and you recycle them back to your local store or wherever you have to recycle them to. So that's obviously getting out of the way, the first kind of power supply that you may use. Now something like this would still drive something like an Arduino kind of project. You know, if you've got a little board, Arduino Uno, it's got a barrel jack on, little adapter, so that you can go from a 9-volt battery clip onto the Arduino, and that will drive this and allow you to run an Arduino for a while, even off of a 9-volt battery pack. Or you could use a stacked up AAA's or AA's to increase the capacity, etc. You know, this will take a sort of 7 to 15-ish, I can't remember the exact range, volts into here, and it will regulate it down to the 5 volts that the board needs. That's great, but it won't power all these other ones. Like on here, I've got a relay board and a motor control board. If you had motors and everything else on here, you would not be driving them through the power that came up here, because you'd almost guaranteed to start interfering with the microcontroller, overload the voltage regulators and things like that. So you'd want to be adding external power, and if you're driving things like motors and other things, it would also be a higher voltage than what your typical battery would provide to you. But nevertheless, you know, for little prototyping and things like that, something like this would easily drive something like this. Now, the other things that I have here, now you can see on the bench, I have quite a range of power supplies. The first and obvious one, if you're a beginner to electronics, is to use something like this. So if you're using a Raspberry Pi or even an Arduino Uno and things, your standard little brick that comes with a cell phone are usually a good bet to drive some of your projects. They will work very well. You don't have to get involved with wiring up mains, so it's pretty darn safe for you to use. All right, you can get some with dual outputs, some with single outputs. Usually, you know, 1 amps, 2 amps. This particular one is 2.1 amps. This one I think is 2.5 amps rating. Nope, that one's actually 1 amp rating. This one's 2.1 amps. This one's 1 amp as well. And you can get lots of different ones of these. There's and they will work very, very well for most small projects where you don't need a lot of power and you don't know anything about wiring up mains and things like that. All right, easy, safe, quick to use. Now, when you have a bigger project, for instance, CNC or some kind of robot arm, or maybe driving some LED lighting and things like that, you need more power. Okay, typically, you know, 10, 20, 30 watts, 100 watts, or even more than that. So what do you do then? Well, the next level that you can do, and I recommend this for a lot of people for projects, is making use of old laptop adapters. Now this one isn't an old one. This one actually I bought from eBay just so that I can have a look at it at some point. This is a 12 volt 5 amp little brick power adapter. It has a standard connector for plugging in a cable, and it has a standard barrel connector at the other end. And something like this is ideal for driving maybe some LED strips or something that you may have bought to put under cabinet lighting or in a closet, or for some animated display that you may be doing. All right, again, nice and easy, safe. You just plug your cable into the mains, you plug that into your project, and most of the LED light strips and things will come with one of these connectors already. And this would even plug into an Arduino barrel jack and drive it, because it's 12 volts, so it's got plenty of it's high enough that it's going to drive the Arduino easily, and you've got a 5 amp capacity. So if you had a few extra accessories, you could drive that as well. You wouldn't be tapping off the 5-volt rail of the Arduino, but you certainly could use the V-in, which is shared up to other ones, or you could put this to some kind of separate connector and split the power out to the multiple boards so that you're not creating noise on the Arduino or something. But either way, things like this are very easy to get a hold of. A lot of the second-hand stores may have these where people have had laptops and they've blown up, failed, died, been thrown away, and the power adapters often will just sit there unused, and eventually they get thrown away as well into the recycle or something. But they are a great source for getting power. Now this is a 12-volt one. A typical laptop battery may be as high as 20 volts and many amps. So it gets you into the realm of doing some quite high-powered projects. You're talking about 100 watts or more. Certainly with the bigger, older gaming laptops, it could even be something like a 200-watt power supply. I know I've got some where they were 21, 22 volts at 10 amps. So that's quite a lot. I mean, you got over 200 watts of power available to you for a project. But what do you do when you go to the next level? If you're going to build something for an installation at home or somewhere else using DIN rails or screwing it even to a panel and things like that, then you want to start going up to something with a little more power. So what I have here are a few options. These ones on the left, these two on the left here, sorry, these two here are from eBay. Now I'm going to talk about these in a separate video, but this one is a 48 volts, great for CNC stepper motors and things like that, but it's only 3 amps, so it wouldn't drive a lot of current, but it's certainly got the volts there so that you can get some good torque out of a stepper motor or a 48 volt lighting project or something like that. Okay, but that's 3 amps on this one. This one here is a 12 volt 10 amp power supply. So the little brick that I showed you here was a 5 amp. This one is a 10 amp. These are both from eBay, and they're relatively cheap. You're only paying, $15, $20 or something like that. I'll put a link somewhere to give an idea of how much you would be paying for these on eBay. But the one thing that you have to be aware of with these is, number one, reliability, and number two is quality and safety. I'm going to show you a few pictures now of some of the boards that I found in these, and I can't find the specific power supply that I had at the time, but I did take pictures, and you should be seeing those up now, where the quality of manufacturing is dubious at best. And 2 of the power supplies that I received via vendors on eBay, if I had powered them up without opening them first, would have probably blown up in my face or blown up some equipment that I had connected it to. So buyer beware when you're getting, if the price is really good, too good to be true, then the product is probably not what you expect it necessarily to be. I got these because I wanted to have a look at what kind of quality they were. I didn't necessarily need them for specific projects, and they do work, but you need to basically strip them down a bit and make sure that all of the connections are soldered properly. In one case, I had the bulk capacitors on the main side. The joints were so dry that the capacitors just wobbled in the socket. And of course, that's no good at all. And if you've got no smoothing, then there's going to be a lot of things going wrong with that power supply. The other power supply that I got, and hopefully I've got a picture that I can show you, it's almost like they've taken the soldering iron and flicked the solder off the end of the iron. All of us electronics engineers do that at one time or another. Usually we do it in a controlled manner and in a safe direction, usually towards some kind of rag or just a bit of the bench where it can easily clean off or whatever. But they had done it on the back of the PCB, and there was a great big solder splash right across the board. And if I had powered that up, it would have blown up because it was shorting out across the mains and things like that. So I don't know how it was tested. Maybe the board was tested before they finished. They did a quick touch up of something, But either way, a big blob of solder was splashed across the tracks on the back of the board on one of these big 10 amp power supplies. Not very nice. Now, this power supply came with some LED lighting that I've got. It's actually the ones that are above me right now lighting this project. This one is R&C. It's still made in China, but it came from a company that I know is much more reputable. They provided me the lighting. I've had a few things to dealt with them for a few different projects for lights, and they do tend to send reliable, good quality equipment. So this is a 24 volt 2 amps, and it's actually designed to drive LED square panels, and I'll link in a picture to show you what it drives. But that's typical for LED like drop ceiling panels and things like that you would use 24 volts. So it's not. This one looks, aside from it's physically smaller because it's not very high powered, it looks very much like the other ones that I've just shown you that I got from eBay. This one is not from eBay, and it's a better quality. So they are out there. They're in the same form factor. You just got to make sure or be aware of where you're getting them from. If you plan on buying a lot of them, then maybe get 2 or 3 as samples and test them before you commit to some bulk order that you might regret later. So that's 24 volt. Now these other ones, let's just ignore this one for the moment. These 3 here are from RS Components. Now all the ones I've shown you up to now I bought. In order to keep things open and above board with you guys, these were all provided to me by RS Components, either for review or for a project like my CNC. So these 2 were actually provided for my CNC projects and my power supply projects and things like that to use, because RS produce some very good quality equipment, and I'm not trying to knock China as an export for bad quality equipment, or Taiwan or anywhere else. Everybody has good quality and bad quality equipment, and you've just got to shop around. Now these 2 are RS Pro power supplies. The one in front is a 24 volt 10 amp supply. The one at the back is a 48 volt 10 amps power supply, and I use this back one on my CNC. The thing to note here is that it's an RS Pro power supply, but it's actually made by Meanwell, which is a Taiwanese company. So as I said, not all Asian, Far East, China, Taiwan companies make crappy power supplies. A lot of them, like Meanwell, make very good quality power supplies and are used by a lot of other vendors in their equipment. And as I say, RS rebrand Meanwell power supplies as RS Pro, and they're very well built. This thing is quite heavy, and I will do a strip down of these in the next video when we start in another video for power supplies as we start looking at quality of build and things like that. But when you look inside here, you can see there's quite a lot of components. There's plenty of space and huge heat sinks for cooling the various components that are inside. Now, as I said, this one is a 48 volt 10 amp supply, and it's also DIN rail mountable. So you've got supports, fairly robust clip for mounting on a DIN rail, great for control projects. As I said, CNCs, one of these will drive a CNC quite happily, and because it's 48 volts, if you're using something like NEMA 24s or bigger kind of stepping motors, one of these will drive 4 of those NEMA stepper motors quite easily. This one here is a 24 volt 10 amp power supply. So the one I've just looked at was 48 volts at 10 amps, so this one is 24 volts. So this is 240 watt, this one is 480 watts. Basically, it's also a Meanwell. It's got power factor correction on this one. I'm not sure if this one does. I wouldn't be surprised if it does, but this one has power factor correction. Mains in, DC indicator light, and outputs are all pretty much the same as on the bigger supply, and same kind of quality of build, and also DIN rail mountable. Now these ones are not too expensive. I will put up the price in pounds as they currently are on the RS site, so that you can see for comparison purposes. And I'm also going to include the ones from the eBay and things, or at least I'll find some current representation of those. Now, the one thing about these, when you get them from RS, is that there's a lot of QA gone into these, and so you know you're going to get a reliable product. It's going to work. You can easily be able to get replacements. Yes, you pay a premium for that, but you have support through RS components. And if you get a faulty product, warranties would still apply within whatever, depending on the region and everything else. But it's easy to get replacements, but you also know they're going to be reliable before you even start the project. All right, so they're not going to be a bad choice to put into something where you're going to be making a living out of it, or where time is money. A lot of hobbyists, they don't really count their time because it's idle time, if you like. They're just doing their hobby. So they don't put a value to it. So buying something from eBay for $50 or $20 versus spending maybe $100 for a bigger one. I can't remember what it is, but we'll have a look in a sec. Post it here, or whatever this one is maybe a little bit more than what you'd want to pay. But as I said, if you're going to make that little home business be reliable and you don't want to have downtime, then you're probably better off spending a little extra money. Even if this is $100, how much are you going to lose by having your application, your manufacturing facility down for a day while you wait for a new power supply to come? All right, so it's worth spending the extra money in a situation like that. If all you've got is some under-counter lighting or something in a cabinet, maybe a decoration that's being used for power, the power supply is being used for the decoration, then if it goes off and it takes you a few days to get a new power supply, probably no big deal. But again, as I said, when you start looking at time and money, then it becomes more important to get something that is going to be reliable. Now, the last power supply I have here right now is this one. This is a recent one that was sent to me from Phoenix Contact, and it's also via RS Components. They're the ones that are sponsoring me, and this is a 24 volt 10 amp power supply as well. So when you look at these two, they're the same power, but look at the difference in size. The Phoenix Contact is just a little bit taller than the Meanwell, but it's a fraction, it's a quarter of the width, and it's the same depth pretty much, within a quarter of an inch. So what gives? The Phoenix Contact, why are they able to get this so much smaller compared to the Meanwell? Well, part of it is when you're building a rack and things, space is at a premium. Space costs money. And so if you can get your power supplies into a smaller form factor, then you're going to be able to get more into that rack and make more efficient use of the space, and therefore it's more cost effective. The other part of this is that its price. The Meanwells are a lot cheaper than this Phoenix one, and they've for ventilation they rely on just airflow up through. They've got the heat sinks, but it's all fairly thin aluminum surroundings and things like that, so you need more airspace for the airflow to go through this. And also, they may be components that can't tolerate the extra heat and things like that. So, again, keeping the price down, providing you a base level of bulk power, but no special features or anything like that, or anything. The Meanwell, and that's the Meanwell ones. The Phoenix Contact power supply, this one, when you look at it, it weighs probably, it feels like it weighs more, but it's not much more. When you look at this one, it's the density of the components inside are packed way tighter than in the Meanwell. But the casing of this as well is a much heavier duty metal casing. So all the components are bonded to it. There's a lot of mounting screws on the sides and things. So all of the heat generating components are going to be bringing the heat out to the outside edges. When you look inside this Meanwell one, I can see heat sinks basically sitting in midair that will be generating heat from switching transistors, diodes, etc. So that needs to dissipate through airflow going through the case. In the case of the Phoenix Contact, no pun intended, case, the heat generating components are connected to the case so that the whole case is acting as a heat sink. They will also be using components in here that will be probably rated to a higher temperature and things like that. Now, this power supply is a lot more expensive than these ones. This one is probably in the order of over £200. So I'll put the price up here as well for this one. But these other power supplies, all of the ones that I have just shown you, are just bulk power. They have a fixed voltage. You can't, there's no adjustment outside to tweak the volts a little bit. Well, actually that's not true. A couple of the eBay specials do have a little trimmer here so that you can trim the voltage a little bit. It's just part of the feedback loop. It's just a little potentiometer, so you can have a little bit of latitude there. But again, you get what you pay for from a reliability perspective. The Phoenix Contact power supply actually has intelligence built into it. Now this is a Quint 4 power supply. It's fairly new from Phoenix Contacts, and you can actually adjust the voltage between 24 volts and 29 volts, so you can compensate for losses in cables and things like that. And it has a whole bunch of status outputs too that allow you to indicate to a PLC or to a panel or something what's going on with the power supply. And the other thing about it is it's got near field communications, so you can take your cell phone to program all of these factors as well. Now I'm not going to go into details about this right now because I'm going to do another video just dedicated to having a look at this, and I'll be powering it up, measuring the voltages and playing around with some of the features to show you what it can do. But again, it's about fit for purpose. So I mentioned before that if you wanted to monitor these, you would have to put some other monitoring device. For instance, I have here a little LCD power meter. So you could put this on the output of any of these power supplies. It will tell you what the volts is, what the current is that's being consumed, etc. It doesn't go anywhere. It just shows you on the panel, which in some cases may be okay, but that's kind of all it does. Or you could hook up a more intelligent power monitor. This one is actually designed for mains, that has, it'll tell you how much power is being drawn by whatever you have connected to it. You can put 3 loads on here and monitor each one independently. And so you could have your power supply, so you're measuring on the main side of the power supply instead of the DC load side of the power supply. But this one also allows you to connect via RS485 out to some other monitoring computer or PLC or something. The Phoenix Contact power supply actually has an analog output. You can choose to have an analog output that will actually be measurable from some other device to tell you how much power is currently being consumed by it. So anyway, I'm not going to say anything much more about that, except that I've now shown you a bunch of different power supply options short of building your own. They're all switching power supplies that go from, basic, well, except for the batteries at the very beginning, that go from 12 volts low power through to 24 volts up to 48 volts. All depends on the application. All of these last few are all DIN rail mountable, which means they're easy to put into chassis, onto walls and various other things. And they're all industrial strength, as opposed to a lot of the other ones that maybe won't tolerate high temperatures and things like that so much. I think the only other kind of power that is good for small projects are things like these. These are actually just, these are 4 amp hour lithium ion, just little USB power, bulk, like power bricks. So you charge them up via a 5 volt USB adapter and they'll give you your project 4 amps. I've seen a few people on eBay, I've seen a few people on YouTube that will often use little power bricks to drive their projects while they're showing people, because then you're not having to worry about any mains being connected. It's nice, clean, safe again. You just have to charge them up, and then everything, each project would be isolated. This could run something for quite a long time, because it's got 4 ampere hours. So you could use one of these almost as a UPS for a project too. But that will be more, again, at the lower end. It's not in, industrial strength or anything like that. So back to these, yes, if I was building a project where I need to have assurance of reliability, then I would at least be going for something like Meanwell power supplies, not the cheapest thing I could buy from eBay, unless I did a lot of homework to make sure it was suitable for what I wanted. And if I wanted to have built-in monitoring and things like that, I'd probably be going for something more like the Quint 4. The reason for that is that it's got the built-in signaling, but if you bought one of the other ones, and then you would have to add the price of some kind of monitoring device onto that anyway. So really, if it can be built into the power supply, then that would be good, and it would save you space, etc., etc. Now, while we're talking about power supplies, I've already mentioned that reusing old laptop battery battery charger bricks is a great source for power supplies for projects. They are, and you just got to find the right kind. And it's not just for laptops. If you've got something which is not too much power, then USB power chargers for cell phones or tablets. Tablets are a great one because they're typically 2 or 3 amp rated at 5 volts, so they will easily drive a Raspberry Pi or something like that. The laptop ones become great if you've got lots of LED lightings and things, and then you get to these kind of bigger power supplies when you start looking at driving CNC's machines, 3D printers, all that kind of stuff. Yes, I know a 3D printer is a CNC, it's just a specific kind of CNC. The other source is things like this. This is, just to close off, this is a power supply that I ripped out of an old broken Epson printer. So it's got your mains in. It's actually a very well built power supply, great isolation from the mains, between the main side and the DC output side. This one happens to have a number of DC outputs. It's probably got 5 volts, 3 volts, probably a 12 or 24 volts for driving the stepper motors, etc. I actually haven't measured this yet. I just recently pulled it out. But these are also a good source for power supplies, old printers and fax machines and things like that. They also give you a good source for stepping motors and ground shafts, etc., etc. I've shown you this one because it is another option. Now, the one thing you have to be careful with this compared to these, and then compared to this, this is safety. This one you have to mount it in a case yourself. You screw it down. You're exposed to the mains, etc., etc. These ones, you've got the terminals where you screw the mains cable in, but aside from that, it's relatively safe because you can't, it's not easy to get your fingers on the contacts or anything like that. And then this kind is probably the almost ultimate safety way of getting power for your projects because it's a brick, there's no screws, you can't take it apart. All you do is you use a standard mains cable in, you plug that into your project, maybe through a buck boost regulator, depending on if you need 12 volts, maybe you only need 9 or 8 or whatever it might be. But these are a great source for powering your projects. And then, of course, ultimately, the safest way for a lot of projects, so if it's a 10, 12, 13-year-old that's doing the projects, you might want to just have some maybe rechargeable batteries in an enclosure, i.e. something like this, that would power them. Now, there are some new ones that you can get. This one only outputs 5 volts, but there are some new ones of these that can output up to 12 volts. So they may also be a good source of power for projects as well, for driving things. But anyway, I just wanted to give you a quick overview of some different power supply options that you may use in your projects. In the next video, I know already that I'm going to be having a look at this one and show you what it can do and talk about some of the features and why they would be useful in an installation where you need reliability and predictive maintenance and things like that. Okay, anyway, hope you like that, and we'll be doing a lot more with power supplies over the coming months, including adding some automation or intelligence to the bench lab power supply and also the DC load. They kind of go hand in hand, so that you can use a microcontroller and control it either from a web page or from your PC or something like that if you wanted to make a little bit of automated lab equipment. Anyway, that's the subject for another video. I'm done here for this one, so Thanks, and see you soon. Bye.